All right, so today we're going to get into molecular geometry as well as hybridization and polarity. The geometry is basically the shape of the molecule. So if I want to, if I'm going to do CH4, okay, figure out the Lewis structure for CH4, it's going to look like this. Okay. And I get on the work for today, I gave you a molecular geometry chart. You will need to, you won't be able to use this on a test or something, so you need to get this in your brain, but for right now you can use that as kind of a reference chart. So this particular, to figure out the shape for this on that chart, the first column says number of electron groups. So what that means is number of electron groups around the central atom. And that could include bond pairs and lone pairs. So there would be an electron group could also be a double bond or a triple bond. A double bond or triple bond just counts as one group of electrons on that chart. So for this one, we have 4 electron groups around the central atom, 0 lone pairs. So this shape is tetrahedral. Okay, and then you can also look at the bond angles. The bond angle is 109.5 degrees for that. Now, polarity. For polarity, you want to look at are the electrons evenly distributed? So a polar molecule means there's an uneven distribution of electrons, so the electrons are going to be pulled towards one side of the molecule versus another. Non-polar would mean that everything's evenly distributed. So if around the central atom it's all the same atoms, the same element, then it's going to be non-polar. The only time it would be polar, if this was the case, is if there's a lone pair somewhere on the central atom. But in this case, it is non-polar. If we had something like CCl, CH3Cl, where we then have a different element, this chlorine is way more electronegative, so it's going to pull electrons towards itself. This would be a polar molecule. Okay. So things you want to look for in terms of polarity are lone pairs on a central atom. Are there lone pairs? Most of the time, if there are lone pairs, it's going to be polar. And then you want to look for asymmetrical compounds, asymmetrical molecules. If it's asymmetrical, that means that one side is going to be pulling harder than the other, and it's going to cause it to be polar as well. Now, the other one I want to look at is hybridization. Hybridization is basically when atoms form bonds, they take their s and p orbitals and make hybrid orbitals out of them in order to contain the electrons within them. So there are really 3 different types of hybridization that we are going to worry about. And it's SP, SP2, or SP3. Those are the different types of hybridization. And it depends on how many electron groups are around the atom that we're talking about. So in this case, there are 4 electron groups around the central atom here. And so we would add up the total number of S's and P's, and that's how many it would be. So since there's 4, we would make this sp3. There's 1 S and 3 P's for a total of 4 orbitals. If there was only 3, it would be sp2. If there's 2, it's just sp. Okay, so something like HCN, where we have a single bond and a triple bond. This counts as 1 electron group, this counts as another electron group, so this hybridization will be 8sp. This one would be sp3. Okay. Again, it has to do with the number of electron groups adding up to the same number of S's and P's. Okay. I think that is about it for this video. Let me check to make sure. Yeah, I think that's about it. So let me know if you have any questions, and have a good day.